Coming up on this edition of The Climate Show, John steps into Gareth's shoes and he does a pretty fine job. Also, he debunks the argument that humans aren't pumping the majority of CO2 into the atmosphere. We also look at the massive storm that's just been in New Zealand, the big chill they're calling it. Is it the biggest storm in 30, 50, 70 years? Well, we find out. Plus, we have some strange and unusual uses for solar energy and solar panels. That's all coming up on this edition of The Climate Show. This episode of The Climate Show is brought to you by hot-topic.co.nz, cyblogs.co.nz, skepticalscience.com, scoop.co.nz, idealog.co.nz, and Kiwi FM.
What good is a drop in the ocean? What good is a drop in the ocean?
Hello and welcome along to The Climate Show. It's a show all about, well, climate change, mostly, but we divide it up into bits and bobs, I suppose. We've got the science, the politics, the policy, the skeptics, and also the solutions. And it's a show that covers all those various areas. Normally, it's myself, Glenn Williams, here, broadcasting live from Auckland City, but not with Gareth Ronalden today, who's normally with us in his homestead in North Canterbury and Waipara. But if you've been listening to the last show, episode number 17, you would have heard that he's gone off on holiday. But filling his shoes today, and normally only contained within the debunking section, is John Cook over at Skeptical Science. But I'm very glad that he could join me here on the show for the whole entire show, or most of it anyway. G'day, John. How are you?
G'day, Glenn. How's it going?
Yeah, very good. Very good. Our main guest on the show is Josh Fox, who is the director behind Gasland, I should say, which was a documentary put out, I suppose it was towards the beginning of last year, written and directed by Josh Fox, and it focuses on communities in the United States impacted by natural gas drilling, and specifically a stimulation method known as hydraulic fracturing, or fracking, as it's also coined as well, the term that people use. And it's becoming a bit of an issue here in New Zealand with a company that's wanting to conduct what's called fracking in Southland. They're already doing it in a place called Taranaki, and people are starting to get worried about this stuff. So I thought I would catch up with Josh Fox, who's been and witnessed the results of fracking in certain parts of the states, and has seen some of the adverse effects on the atmosphere, but also the water supplies in those areas as well. So he's our main guest on the show. What are you debunking today, John?
Well, the latest fad that's gone across the internet over the last few weeks has been, it's an old myth that's kind of got reheated and rehashed, that saying that humans aren't causing the rise in CO2 levels. So I'm going to have a close look at that. Okay,
excellent. Don't forget that the show goes out in a couple of flavours, video and audio. So if you're listening to the audio, you can check out the video, or vice versa. If you are watching the video but you want to take us on the road and it's easier for you, then there is the audio as well. All available up at theclimateshow.com, and all the show notes and links to everything we're talking about also available up at theclimateshow.com and hot-topic.co.nz. And don't forget to subscribe as well in your favourite RSS player, whether it be iTunes or something else, perhaps something on your phone. You can also get us through Stitcher.com and download the app to your smartphone as well. Well, let's get into the news, and I've certainly been experiencing this firsthand, even in Auckland in the far north of New Zealand. The worst snow blizzard or worst storm to affect New Zealand in 50 years. Well, at least that's what The Guardian was saying. There's so many different stats being thrown around about how bad the storm this week that we've had. The Guardian was saying heaviest in 50 years. Other sources were saying this is the worst in a generation or 2 generations. Some other source said it's the worst in 70 years. It's broken records all over the place. In Auckland, we saw snow. Now, there was a little bit of debate about whether or not snow was actually seen in Auckland, but the officials at the Met Service have said that yes, indeed, it did snow, perhaps in downtown Auckland, certainly south of Auckland it did. But the debates got very specific about what exactly is snow. And Philip Duncan over at Weather Watch said, well, snow is water vapour that is turned into crystals. The crystals start to join up, and that's what makes the pretty snow symbols. And each one is different, but they are all hexagonal. What is hail? Well, hail is frozen raindrops or water droplets. What is sleet? Sleet is rain that contains ice or snow that is melting as it's falling or as it hits the ground. It's mushy. It falls flat on the ground, no bouncing, and sounds like rain. I'm pretty sure I saw some sleet at my place. And a new term that we all learnt here in New Zealand over the past couple of days is something called groupal. Have you heard of groupal, John?
No, unless it's a content management system, but I think that might be something different.
I've heard of that too. Well, it's very similar to snow to the naked eye, but more like soft hail. It is little round soft balls of ice which can bounce, but it can also float in the wind as it's not as heavy as hail. So I think a lot of people thought they saw snow in Auckland. They actually saw groupal, but it melts quicker than hail and is softer and doesn't have a snowflake shape. So throughout this whole process of the storm that we've just had, there's been a lot of learning about what is hail, snow, and groupal and sleet. But certainly it did snow further down south. Wellington saw the heaviest snow that it's had since 1976. I think the stat on that was. And of course the South Island, which sees snow every single year, is no surprising there, but they've seen some very, very heavy falls. Got a satellite image of what the snow looks like from space, as we see up there in the north of New Zealand. Just usual. It's usual. It's green, but it's not until we get around to just below Taupo, around in this region here. There's snow under those clouds, and then down to the South Island, a nice dusting over there as well. So very good for the ski fields in those areas. There was a really slow start to the season, and I know a lot of ski bunnies and snowboarders were a little bit concerned about whether or not they'll get to use their lift passes this season. But certainly, I think that the amount of snow that's been dropped is going to carry them through for another couple of months or so. That's for sure. So it has been also a year of extremes. Auckland's warmest February and May on record, but then we just saw our coldest day on record, 8.2 degrees Celsius it was on Monday. That was the maximum temperature, daytime temperature in Auckland City. So far, it's been a year of extremes. Now, that's something, of course, climate scientists have been saying that, with global warming, with climate change, that we're going to see more of these types of extremes. And certainly we're talking a lot more about the weather than we used to. And I know it's dangerous, John, to draw links between climate change and single weather events. But at the same time, it's been a pretty extreme year, right?
Yeah, and not just in New Zealand, but we in Queensland have experienced some pretty extreme weather as well, and globally, and the extremes that are relevant here are one prediction is that as it gets warmer, well, it's not just a prediction. This has been an observation that as it gets warmer, we will see more moisture in the air, and then that will lead to more heavy precipitation events, and that can either take the form of heavy rainfall, or if the temperature is at that right range, then we'll get snow events. And as I understand it, what's been happening in New Zealand is you've had this cold front coming up from the Arctic, and then that's met with this storm system to the northeast, I think, which has sent a lot of moist air over New Zealand. So when that cold front collided with the moist air, that led to all this snow and sleet and all the storms that you've been having.
Yeah.
And the other point is that in terms of cold snaps and heat waves, what we expect to see is more heat waves, and what we're observing is twice as many heat waves as cold snaps. So you will still get the ups and downs of weather and have a record cold day here and there and a record hot day.
Yeah.
But the ratio of hot waves is increasing.
And of course, no matter whether or not it's an extreme event or a normal event, meteorologists can pin a single event on a certain weather system. In fact, NIWA in this particular for this particular cold snap have been saying that it's a big storm, and it's because of two opposing weather patterns that have come together. A low pressure centred east of New Zealand came down from the North Tasman Sea and has brought quite a lot of moisture with it, and that's met up with a cold airstream coming from the far south. So that's cooled down, and the moist air and caused all the precipitation, be it rain or snow or whatever. And the airstream was flowing all the way from, say, Scott Base and Antarctica, so all the way up to New Zealand. So we were getting air directly off the Antarctic ice shelf. That's why it's been so cold. And it's still cold, really cold outside at the moment, but more frosty, which means some nice clear days in Auckland. In fact, I think they're predicting the next 9 days to be nice and clear, which has got to be good. So yeah, it's been an event, that's for sure.
It's funny how just over this winter we've had 2 cases of Australia getting this cold front from the Arctic, and then you guys got it as well.
Yeah.
A few months later. And I wonder whether over the next year or two the scientists will start teasing out whether there's shifting patterns in the Arctic circulation and just the way maybe there's a change in the way Arctic circulations are pushing air up towards us. So yeah, it'll be interesting to see how that evolves.
Yeah, I mean, it'd be interesting to see if that work is being, if that study is being done now.
But the main thing I'd like to know is, has all this snow disrupted production of the Hobbit movies?
I was thinking that the other day, and I was thinking, well, because they spend huge budgets on these big films, and a lot of that budget, would have to be spent recreating certain weather events. And I'm pretty sure that I haven't read The Hobbit, but it must have snowed a bit in The Hobbit, right? Are you a Hobbit reader?
When I was 12, but
well, if there is snow, then they needed to quickly do their winter scenes in the snow that was provided for them in Wellington. Yeah, I don't see why not.
As long as I get my movie in December 2012, that's the main thing.
Is that when it's due for release? Is it?
Yeah.
Yeah. And talking about that, just up on the screen now, right over Wellington was their major snow event, and that's the rain radar that we're looking at back on the 14th of August. There's a great blog on this up at themetservice.com, but I'll put those in the show notes as well. It basically explains the storm almost hour by hour and how it unfolded. Actually, now looking at pictures from 1976, the last time it snowed properly in Wellington. And the event looks kind of similar, really, but certainly not that snow in Auckland. That didn't happen. Alrighty, on to the next story. We're looking at Arctic sea ice loss, and I know we briefly touched on this in the last show, but I don't think any stats were out on this just yet. There was some thought that we were tracking towards the lowest level of ice in the Arctic on record. Is that still the case?
Oh, it's kind of hovering around. Like 2007 is when we had the lowest sea ice extent, and by extent I mean it's how much ice is floating basically on the surface of the water. And in 2011 it dropped below the 2007 minimum. It popped back over again, and so now it's kind of it could go either way.
Okay.
And a lot of blogs around this time of the year, because we're heading towards September where we hit the minimum, everyone starts obsessing over will it break the record or not, and people start laying bets on what the amount will be. But with sea ice extent, that's driven partly by climate change, but also by local weather events, because the way the winds push the ice around can have a big factor on what the sea ice extent will be. And in 2007, a big contributor to that record low was just the wind patterns would pushed a lot of sea ice out of the Arctic. So now we've had those patterns before. What's happening over the long term is the ice is actually getting thinner, as well as the extent going down, and so consequently in 2011 the sea ice is a lot thinner than it was back in 2007. So the really metric or measure of Arctic sea ice, what's happening there, is the sea ice volume, which is the total amount of sea ice. And when we look at, I think I put a graph up there of sea ice volume, and it shows that in 2011 it actually reached record low values. So it's well below the 2007 minimum, because see what you're showing there is sea ice extent. That's what's happening on the ocean surface.
Yeah.
But if we can bring up sea ice volume, you see that because the ice is getting thinner, it's actually dropped well below 2007 values. So that means that Arctic, yeah, there we go. So in 2010 it hit a record low, and in 2011 it's dropped even lower, and so there's this myth that you still see on the internet saying that Arctic sea ice has recovered since 2007, and that's clearly not the case, as we see here, because it's got thinner, and there's a lot less ice now than there was a couple of years ago.
Yeah, the official blog on this over at the National Snow and Ice and Data Centre, they say that this was their update on August the 16th, so this is really fresh. Arctic sea ice loss slowed down in late July through early August. Then over the past week, so this is right up to now, the rate of ice loss sped up. At present, there is more ice than at the same time in 2007, which saw the record minimum September extent. I mean, will this sound alarms if it drops below 2007? What are your thoughts? Do you think that people are going to stand up and notice?
Well, it's hard. I mean, you can almost imagine what the denialist fear will start, how they'll start spinning this, even if we do drop down. I guess next year they'll say our sea ice has recovered since 2011. So I don't know. It's hard to say what will get people's attention these days, because you'll have extreme heat waves like we're having in America, and somehow people fail to join the dots. And then we're having Greenland losing ice at an accelerating rate, and people are still failing to join the dots. So maybe it's just a accumulation of all these different bits and pieces gathering momentum that will finally start to get people's attention.
Yeah.
I'm not sure what that public tipping point
no, what it will be. Hey, you just mentioned that that the States was having this heat wave. Well, the stats come through from the National Oceanic and Atmospheric Administration, reporting that July was the fourth warmest on record in the United States.
There's a good graph. I wish I had it up. I did have a look at it earlier today, so I could bring it up now if you like, while you're
yeah, sure,
and then switch it over, which just looks at heat waves in America, and it compares the number of heat waves to the number of record cold snaps, and it found that the number of heat waves has gradually been getting, or the ratio of heat waves to cold snaps has gradually been increasing over the last 20, 30 years, to the point where at the moment it's about double the amount of heat waves, and they predict that to increase even further. Here it is, found it. So all right, let's try a new experiment with Skype and the climate show. I'll see if I can switch my screen to come up.
And while you're doing that, I've just got some numbers and figures on that the heat wave, or the average temperatures in July. The nation's average temperature was 77 degrees. This is Fahrenheit, of course, almost 3 degrees above normal. And states like Oklahoma and Texas had the hottest July ever, with average temperatures of 88.9 and 87.1 respectively. And Oklahoma's statewide average temperature was the warmest for any state for any month on record. All right, let's see what you have on screen over there. Okay, so you've got a graph there.
So this is looking at all temperature records over the whole 48 contiguous United States. and showing how whenever there was a warming trend from the 70s to the 2000s, the number of highs was increasing compared to the number of lows. And then what they did was they predicted how that would evolve further into time. So we see from 1950 to 2010, it was steadily increasing to about double. So the two there is like double the amount of heat waves. And then they predict that by 2050, there would be about 20 times the amount of heat waves compared to cold snaps. And by 2100, it'll be up to about 50.
With the warm snap going on, although can you call it a snap if it's warm? The heat wave that's going on over in North America, and the extremes that's happening down here in the southern hemisphere at the same time. Do you think scientists will be working on drawing lines between the two? The fact that there is a global system and both are happening at the extremes at the same time. Do you think they're going to be looking at that?
Oh, I mean, they're definitely working at it, and the biggest problem is it requires a lot of data before you can start to tease out statistically significant, meaningful results out of all this weather. So that's why when there are a few studies that look at like global precipitation trends and like that study I just showed that looked over the whole United States. And there have been a few that look at, like there was one that looked at just a single heat wave in England to try and work out the human contribution to it. So I think that's an area of study that is just starting to find its feet, I think, in quantifying just how much of the human influence is in this extreme weather.
Well, that wraps up our news segment, unless you've got anything else to add, John?
No, that's good. All
right. Well, I'm very shortly going to move on to the feature interview, who is Josh Fox, the man behind the documentary Gasland, looking at hydraulic fracturing or fracking. But before we move on to that, I do want to thank a couple of media partners who have helped us out here with the show. One being scoop.co.nz, who posts the show whenever it goes out and do a great job on covering news and events from New Zealand, but also around the world. But also Idealog Sustain, who've come on board and are also putting the show out for us. Idealog Sustain are a small section of the idealog.co.nz website. At the moment, they're actually featuring a story on hydraulic fracturing. It is becoming quite a huge issue here in New Zealand. But we've also got urban design in there as well, talking about electric cars and also talking about a greener Wellington. So there's a whole lot of stuff there to go and check out at idealog.co.nz. Just click on the sustain section of that website and then you will see it all there. But I suppose we should get our guest on. I just caught up with Josh Fox a little bit earlier, so John unfortunately couldn't join in on this one, but here he is. I caught up with him a little bit earlier. All right, well, let's talk fracking, or hydraulic fracturing, as it's also termed as well. It's the controversial practice of extracting natural gas from shale rock by drilling, planting explosives, and then pumping vast amounts of water and chemicals into the rock to open up gas deposits. It is commonly referred to as fracking. Domestic hydraulic fracturing is being touted by governments and fossil fuel corporations in several countries, in fact all over the world really, as being cheaper, safer and more climate friendly than oil or coal, gas or any other kind of extraction, as well as less dependent on the instability of international markets and political situations than other fossil fuels. So it's been an issue not only in the States and other countries, but also now starting to be an issue here in New Zealand as well. A documentary film which came out in New Zealand last year was called Gasland, and it was written and directed by Josh Fox, and the film focuses on communities in the United States impacted by natural gas drilling, and specifically a stimulation method known as hydraulic fracturing, and that's what we're talking about with Josh on the show today. He's joining us from his cabin out there in the woods in New York State. G'day there, Josh.
It's not a cabin, it's a house, but that's okay.
It is the very same house, of course, that features on the show, and actually that's where I want to start off with. The documentary, would be fair to say, started off in a very personal way, didn't it?
Absolutely. I mean, it was about leasing this area, this land, which for with our house, it's about 19.5 acres, about 20 acres. And then discovered that this entire Delaware River Basin was being leased for natural gas drilling. And that was very disturbing because this is a watershed area. It's a pristine area. As you can see in the film, it's not a place where major industrial development was going on. And a lot of people here were persuaded by the enormous amounts of money that they were throwing in people's faces. And that created a controversy here, which I went and investigated in terms of the real process of hydraulic fracturing and what it does to the land, what it does to the water under the ground, what it does to air, what it does to people in terms of health problems from exposure to the toxic substances that both they use in the drilling and that also come up with the gas. And that sent me, across the United States on a road trip to investigate hydraulic fracturing for natural gas as it is happening across America in 34 states. And then when the film came out, that put me on a world tour to investigate the process across the world. So I've been to Europe, I've been to Australia, I've been to South Africa, I've been to Canada, I've been all across the United States, continuing my investigation into the process. And unfortunately, it's going the same everywhere I go and everywhere it goes, which is to say that it contaminates water supplies. There's something going really wrong in the process, or the process itself is intrinsically bad. We don't know the answer to that. But gas and the chemicals from the drilling fluids, which are carcinogenic, migrates into the aquifers that they drill through. And that contaminates water supplies, as well as the wastewater, which is an enormous amount of wastewater generated by the process. They use between 1 and 7 million gallons of water laced with toxic chemicals to do this hydraulic fracturing. All of that becomes toxic waste, either stuck in the ground in the well as they injected it, or brought back to the surface, which then has to be disposed of, and that waste is being disposed of willy-nilly.
How can we quantify that amount of water? What does that amount of water look like? In other terms,
it's like toxic sludge. When it goes in, it's fresh water. So when a gas company will come to your area, they'll find a river, or they'll dig a well, or they'll drain a stream, or they'll drain a lake, and that gets transported by truck in these massive, they look like shipping containers, tanks, and those are all lined up on the well pad site, hundreds of those at a time. They're daisy chained or manifolded together, and then the frac pressure trucks come in, and those force that enormous amount of liquid down the well bore, and that is mixed with these various chemicals at various stages of the process that either thicken the fluid, or they lighten the fluid, or they make it more lubricated, or there are chemicals injected so that the well itself doesn't freeze or doesn't corrode. So you're talking about biocides, you're talking about cross-linkers, foaming agents, gellants, sealers, all these things that are these proprietary chemicals that the drilling companies use, and those are forced down with this enormous amount of water. Then when the rock is fractured, when this pressure is exerted by the water on the rock and it's cracked open, they have to bring that liquid back up out of the well, and that is stored initially in a waste pond or tanks on the site, and that is a toxic sludge. It's mixed in with all the volatile organic compounds that come up with the gas, benzene, toluene, xylene, these things that are very dangerous to human health, and the fracking chemicals. It's this one big toxic mixture. In fact, it is one of the most hazardous toxic wastes in America. And you're talking about per well, each one of these wells has millions of gallons of that fluid that has to then be disposed of somehow. There are a number of ways which you see in the film by which they dispose of it. They spray it into the air out of those pits so that it evaporates in the sunlight, something really insane for people living nearby. Or they will bury the whole pit with the toxic sludge at the bottom, or they'll take the sludge out and do something called land application or land farming, where they take the toxic waste and till it into the ground.
Yeah.
Or they'll inject it back down into the ground lower through injection wells, which are known to cause seismic activity because you're essentially lubricating the tectonic plates down there with this toxic fluid. Or they just dump it into the river, as we've seen in many cases in Pennsylvania. And there was it was a series of New York Times exposés about the wastewater and how it was radioactive and how it was being dumped directly into public drinking water supplies. So this is something that we've managed in the United States to create the worst possible way of dealing with this process that is as toxic as it could be to the citizenship, and as I guess cheap for the gas companies to do it as possible.
Yeah.
And a lot of these techniques are also being employed across the world, not just in the U.S.
Now, if it's as bad as you say, and it's as bad as you see in the film Gasland, you'd think everyone would be talking about this, right? I mean, how much did you have to dig? How much did you have to push in order to find out all this, and find out the problems? Was it obvious as soon as you got into these places, or did you have to dig?
It's a great question. It's a great question. In terms of making the film and finding people who wanted to talk about this, really very, very easy. Because I would roll into a town, I would be set up with one interview of somebody had connected me from one state. Says, oh, you really have to call this guy in Texas. So I go down to Texas. And, oh, you'd really have to talk to this person in Colorado. So I'd head out to Colorado. I'd roll up in a town, and within a few hours, would have 15 interviews. And I would be working until 2 in the morning. Right. Because there were that many people who wanted to speak about what was happening to them. The problem was so widespread, and that there was so little media attention on the problem. This was in 2008 and 2009. We had a lot of big changes in the United States. There were other things the media were preoccupied with. Yeah. But then when the film came out, it came out at the same time as the midpoint of the Deepwater Horizon catastrophe, which was probably the worst environmental catastrophe in United States history. And as a result, people were thinking about oil and gas and how polluting they are. And they are very, very polluting to develop in any way. But this debate really ignited, I think, in America because New York and Pennsylvania and the area where I'm in, we've never had this kind of massive industrialization for oil and gas proposed. It's different than in Texas, Colorado, some of the more traditional oil and gas producing states. We don't have that here, and we have an enormous amount of people. I mean, you're talking about 16 million people are dependent from the water from this area, and the gas companies are just pushing in, bullying, used to getting their way, and they've had a big fight on their hands the last 3 years. Gasland, I think, showed how prevalent the problems were. And
is this only this issue of fracking only come up now because not only the technology has become available to do it, but also it's become cost effective, because in the past it would have been too expensive, but now with the price of gas and the price of fuel going up and the shortage perhaps of fuel that we're seeing on the horizon, that it's now only cost effective, this desperation to get as much as we can out of the earth?
That's one of the factors, I think. There are two key factors in the United States. One is that in 2008, when you really had this process at its height, you had gas prices very, very high. So it was economically viable to do this thing. The other thing is that in 2005, the natural gas industry was exempted from the Safe Drinking Water Act, which is one of our primary public health and safety and environmental laws in the United States. Dick Cheney and George Bush and their Energy Task Force, which was a special commission appointed by the Vice President, had been pursuing an exemption for hydraulic fracturing to the Safe Drinking Water Act since the day they walked into office. Dick Cheney was the CEO of Halliburton, one of the companies that pioneered the process, from 1995 until 2000 when he became Vice President. And he came into office with this objective so that they could get this form of drilling exempted from the very law that protects groundwater for Americans, because that law was standing in the way of their development. By 2008 and 2009, they had done this quite a bit out west, and there were a lot of problems, but the West is not a major media zone. I mean, there's fewer people, there are fewer media outlets concentrated on it. When they started to propose it for the East Coast, they ran into a whole different wave of people, a different political climate in these states. And I think they didn't know, I think they were out of their league a little bit in terms of how much opposition they would find. At the same time, however, this process has been promoted all across the world. New Zealand, Australia, France, South Africa, England, Spain, Canada. And so you have a kind of schizophrenia going on. On the one hand, most intelligent people will recognize that we have a real climate crisis, and that we've sustained an enormous amount of damage from fossil fuel development to water supplies. At the same time, you have big business, gas industry, oil and gas industry being one of the most powerful industries in the world, bearing down on our governments, lobbying them to the tune of hundreds of millions of dollars to promote a form of extraction which is both unhealthy, unsafe, untested, to continue our addiction to fossil fuels in an antiquated model that we have to move beyond, or else we're going to be in severe trouble as a society. We have to develop renewable energy, and this proposal to do shale fracking worldwide is the direct competition for renewable energy moving forward.
Wind and solar and whatnot. Now, of course, there are the champions.
Wind and solar and whatnot.
Yeah, well, you know all the good stuff.
It's the future of the planet. It's as if you had said the internet and whatnot.
Yeah,
but wind and solar
okay,
is the way
it's
going to run the world from here on out, or else we are going to continue to suffer the contamination of fossil fuels or of nuclear, as you saw in Fukushima, as you saw in the Gulf, as we're seeing every day with fracking or with mountaintop removal for coal. All of these things are incredibly damaging to an environment that needs to be sustained if we're going to head towards 9 billion people on the planet Earth.
And I only take that attitude with renewables because I think it's a no-brainer, of course. I mean, that's the only way forward. But anyway, there are...
I was just poking fun at you a little bit.
I know. There are, of course, the champions of fracking, and there's an opinion piece in the Press, which is a major newspaper in the South Island of New Zealand. Bernie Knapp writes in the Press, and he addresses... he talks about your documentary. He says US documentary Gasland, which has been doing the rounds in New Zealand, presented spectacular scenes of residents setting fire to their tap water. Now, he says official investigations in Colorado and Pennsylvania have shown that affected water bores had been drilled through shallow coal seams and that the lining of the bores had corroded. As a result, the thermogenic methane migrated from the coal into the drinking water. This has nothing to do with fracking, he says.
Oh, of course, it has nothing to do. This is very, very similar to the way the tobacco companies used PR firms to try to dispute the link between smoking and lung cancer. In fact, the gas industry has hired the exact same PR firm that defended the tobacco industries for decades, in saying that lung cancer was a naturally occurring thing, and then in some cases they actually said smoking was good for you. And by the same token, the natural gas industry is saying that hydraulic fracturing is good for us and that it's going to save the world. In short, this article and this person, whoever he is lying. Completely lying. And the information is easy to look up. At our website, gaslandthemovie.com, we put out a 45-page PDF which basically counters all of the negative industry spin and PR against our film point by point. And very clearly this issue of naturally occurring. It's as if the gas industry is saying something like, well, these people could light their water on fire before we got there. It's kind of absurd. We also know that this is the exact kind of gas that they were drilling for. The Pennsylvania Department of Environmental Protection, in fact, verified and ordered a water line for residents, saying that the gas companies were at fault. In our film, we show the story of Amy Ellsworth, Colorado Oil and Gas Conservation Commission, the regulators themselves, who very often collaborate with the gas industry, admitted that there was, in fact, impacts from natural gas drilling on their water wells. As well, the New York Times, I think it was 2 weeks ago, or less than that, came out with a blockbuster front page article that showed the EPA has known since 1987 that hydraulic fracturing can contaminate water supplies, and showed the direct causal link between the fluids and the aquifers in that hydraulic fracturing case. This is simply a load of nonsense, and it's PR, and they have an enormous amount of money to spend on PR. What they don't have is the truth. And you can look at how much money, for example, Gasland spent on our PR, and that the message is very clearly resonant with people. It's a lot more expensive proposition to promote a lie than it is to simply show what's happening to people on the ground level.
But you see, in New Zealand, we like to think ourselves as slightly different. We like to think ourselves as 100% pure, as our marketing statement worldwide goes. But continuing with this article in the press, he says New Zealanders have no concern on that score when it comes to air quality and water quality because we do not use the volatile toxic chemicals that have been used in the US, and we have different methods for disposing of waste fracking fluids. Just to make it absolutely clear, he says the toxic BTEX chemicals, which include benzene and toluene, I think I said it right, are not used in fracking in New Zealand. And in our country, in the concentrations used, fracking fluid is non-toxic to humans. But he says that's not an invitation to drink it any more than you would drink dishwashing water.
Well, this is exactly. I'm very glad you brought this statement up because if those of you in the audience are familiar with Shakespeare, you remember the witches from Macbeth. The witches from Macbeth tell Macbeth that he's going to be the king, and he's like, "Hooray! That's great! I'm so happy." But then what they leave out is that he's going to have to kill all of his friends, and that he'll never sleep again. His wife's going to go crazy, and he's going to be dead in 3 days. That's the part of it that they didn't tell you. And this is exactly the way the gas companies work. They equivocate. They tell you a half-truth that sounds pretty good. They're saying they do not use BTEX in their fracking fluid, the benzene, toluene, ethylene, and xylene. However, BTEX is already in the ground near the gas. The gas comes up with BTEX, and these things are carcinogenic. So when the gas is coming to the surface, which is where you need to worry about it, it's actually infused with those BTEX chemicals, benzene, toluene, ethylene, ethylbenzene, and xylene. So when you have that wastewater, it includes BTEX, and when you have the smoke coming, or the emissions coming off the top of the gas well, that would also include BTEX. So it's a perfect example of the kind of half-truth, the equivocation, which to me is, you tell a little piece of the truth and that conceals the much, much bigger lie. And that those kinds of statements are designed to assuage people, to make them feel like, oh, this is going to be fine. We don't use the same nasty stuff that they use in America. I don't buy it for a second. And because I'm looking at the logic, and I've heard these kinds of statements many, many times before. And any person who actually knows what they're talking about can pierce them and punch a hole in that lie quite easily. But it is a kind of chemically and technically complex process, which sounds to the layperson and maybe many reporters as if that had the ring of truth, but it couldn't be further from it.
Well, I should let you know that Bernie Knapp is a senior policy analyst for Stratera, the industry group for the New Zealand resource and mining sectors. But he does say...
So it's an industry group statement.
Yeah.
I have told you that without you telling me, because I know the pattern of the lies that they tell.
He does. He also does say here, and I'd imagine this is possibly what the residents of Colorado and places like that heard. He says here that fracking operations occur deep below the water table. The possibility of fracking fluids getting into the drinking water is extremely remote. Certainly it has not occurred in New Zealand. I'm sure that is what most people have been told around the world, right?
Well, it's extremely remote to have fracking fluid, to have anything from that layer migrate into the aquifer, which is far above, unless, of course, you've connected those layers by drilling through them.
Yeah. Which is
you drill through the water table to get to the layers that you're targeting for drilling, and then you are presumably extracting something from down there through the water table back up. If there's any problem with a well casing, which is the part of the well which is 1 inch thick, which is made of cement, if there's any problem with that cement, you have a problem. You have communication between layers that are 8,000 feet down, locked away for millions of years with these harmful substances that we use to burn things with. And the industry will tell you by their own admission that 1 out of every 20 well casings fail immediately upon drilling, which means to say, if you've drilled 100 wells, you're going to have 5 problems, and those 5 problems could be massive in scale. They could be 9 square miles, as we saw in Dimock. You could have contamination of these chemicals or those fluids permeating through those aquifers, causing plumes. One we had in Clark, Wyoming, 26 miles wide. That would mean that the water for that 26 miles is contaminated. It cannot be used. It cannot be used forever, because it's very, very difficult to clean up a river where you have a spill at the surface, or the Gulf where you have a spill at the surface. When you have a spill under the ground, virtually impossible to clean
Is
because all that contamination is stuck to that underground formation. You know, you're talking about risking permanent contamination of underground drinking water sources based on 1 inch of cement and statistics that say, 5% of the time that's going to fail. If you had airlines that were running where you had 5% of the planes failing,
Yeah.
you wouldn't have airports.
Yeah.
Airplanes operate to 99.99 or 6 nines in terms of any problem. So they're not operating on a standard that puts human health and safety at in any kind of correct perspective. They're operating so that they can make money. That's all they're doing. And a lot of us would argue that developing fossil fuel is wrong, period. We should be developing less fossil fuel. We should be moving off fossil fuel, not developing more of it.
Is one of the issues here when it comes to regulation is that we're early on in the cycle of this technology, much like, let's say, back in the 50s, early on in the cycle of cigarettes, that scientists haven't had the official time to put together all the body of research to then go to governments and say, hey, we shouldn't be doing this.
I would say that's a very, very good analogy. I'm sure that 50 years ago people were dying of lung cancer and they would figure out, well, why is this happening? I think the same thing is happening right now. You're seeing people getting contaminated. You're seeing homes being ruined, lives being ruined, entire towns being made uninhabitable. And it's really tragic. And I think it's a race for the science to catch up. But I think that we cannot wait that long. We can't take 50 years with this. We have to do this quicker. This process has to be banned, and we need to move on as a nation, as a world. We need to move on to the forms of energy. Look, no one was ever killed by a solar panel, and in your part of the world and in mine, that is an incredible, a wonderfully viable form of energy that is vastly underutilized.
That is, it's such a stark thing that you just said, because I was saying that to my partner at the end of watching Gasland, where you see all the wind turbines, and she said, "Oh, I can't believe people don't want this stuff on their land. There's actually some beauty in it." And I said, "Well, yeah, and no one that I know of has died standing next to a wind turbine."
Well, there are some problems with siting huge wind development projects because there is a vibration and there is a hum and there is a danger to migratory birds. But these things are vastly less damaging than the permanent contamination of the water supply. However, offshore wind is a great idea, and you guys are in an incredible situation there for wind and for solar. And that, you've got more wind in the United States in just 3 states, North Dakota, Kansas, and Texas, then we need to power everything in the country, including our fleet of 200 million cars. We are sitting on that resource. The main problem, as I see it, oil and gas have been running the world for 100 years. They are entrenched. They have an enormous amount of influence on Congress and in the United States and on governments all across the world. And they are willing to spend a lot of money on PR, a lot of money on lobbying, and they have a lot of money to throw around and put in people's faces. We need to make this transition as one world going forward. And that, in my extensive traveling around the world and around the U.S., looking at this problem, that is what's happening. And I think that the gas industry is actually bringing it on themselves faster than they would have if they hadn't been so bullying and aggressive. Because what's done is created a group of people like myself, and these are millions across the world, who now need to move to renewable energy or else we will lose everything. If this area is drilled, I won't be able to live here anymore. I was with people just 2 days ago in central Pennsylvania who have had to move out of their houses because their water supply is contaminated, who have had to move out of their houses because their air was so polluted that they could no longer stay there and they were having health problems. I've heard this story again and again and again. They stood and fought until they had to move, and then they had to abandon the areas that they loved, that they built houses in, that they lived in their whole lives. And this is what will happen to so many of us if the gas industry moves in, and that is creating a political force on the ground, an enormous amount of political will towards renewable energy. And so there is one small hopeful thing about this, which is that the advancement of renewable energy, wind, solar, geothermal, the non-polluting forms of energy creation, are moving faster and are on their way, and that's exciting.
So Josh, having done all this travel, I guess, since Gasland, are we going to see Gasland 2 on the way, or another documentary?
Absolutely, we're making it right now, in fact, and we shot a good deal of Gasland 2 in Australia. Unfortunately, we did not get to New Zealand, although I'm holding out hope. I've heard so many amazing things about your country. I am dying to visit and stay for a while. I saw an incredible documentary that was the New Zealand documentary. It's one of the ones that was shortlisted for the Academy Award. It was called This Way of Life, I think.
Yes. Wonderful. Yeah, about the family on the horses.
Touching film. Unbelievable film. And it just made me think. Also, I had friends of mine in my other life as a theater director. I've done a lot of work in Thailand, and people who worked on Lord of the Rings.
Of course.
And so I've heard tales of the beauty and amazingness of New Zealand for a very, very long time, and I'm very excited. At some point, I'm going to get down there. So.
Well, the Hobbits will be released very soon as well, or Hobbit. That's being worked on at the moment. Yeah. Hey, Josh, really nice of you to
put it out at the same time as Gasland 2, because you know.
Yeah, contrast the two. Hey Josh, really nice to have you on the show, and if Gasland is screening on a TV screen near you or at a cinema near you, make sure you go and check it out. But Josh, thanks for your time joining us in New York there.
Thanks very much, and I appreciate the time.
Alrighty, now it's time to debunk the skeptic, and we do that, of course, with John Cook, bringing him back into the show, even though he's been here the whole time, except for the Josh Fox interview. Welcome back after that wee interlude, John. Of course, over at Skeptical Science, that is your business. That's what you do over there. You debunk the skeptics. And in fact, actually, do you want to talk about, before we go into the particular topic today, which is debunking the argument that humans don't cause most of the CO2 that's pumping into the atmosphere, you're starting a new section on the site.
Yeah, I've actually been working on this for months and procrastinating finishing it. So, and I still haven't released it on the website. But I figure if I tell you now, that means I've got a 1-day deadline to force me to publish it. So,
and your time starts now.
All right. So let me try this experiment again, and I'm going to share my screen.
Great.
Now, what we're creating is a resource of just all the different climate skeptics and what the articles they've published, what the climate myths they like to use, and what the skeptical science rebuttals are to all of their myths. And the reason I'm doing it is because lately I've just been getting this flood of emails from people saying, "Oh, I heard such and such say this," or "Someone said that. What's the answer to it?" And often the answers are on my website, but people are just, I guess, not finding them. So I'm just trying to create other ways of getting to that information, and one way is by grouping them by person. So what I've got here is we've just included all the different climate skeptics who we've already done blog posts about, or for some of them we've even done entire series. So for example, when we click on Christopher Monkton here, and we've paid way too much attention to him, and like if you click on all the blogs we've done, there's probably about at least 20 of them there. And so, but what we also list is a selection of quotes from Monkton, just some of his pet myths, and then what the science says. And then if you click on what the science says, that will give you a full rebuttal.
Great. So it's a way that makes sense, because a lot of times people will hear about this stuff from a particular skeptic, and it's easier for them to just go and look for that skeptic and look for their common arguments rather than looking for the argument itself. This makes sense.
Yeah, it's just another way of getting to the information, I think, and the more avenues you can get to the final destination, the easier it is for people, I think.
And just while you're on the Monkton thing there, and I meant to talk about this at the top of the show. So he came to New Zealand last week or the week before, I think it was. The fact that I can't remember is probably a good thing. He and of course there was a little bit of fuss about whether or not he would be getting any attention here. And it turns out he actually didn't. All the scientists decided that they wouldn't debate him. Most media didn't really talk to him. I think there was one TV program that I don't think anyone really watched. It was early on a Sunday morning. No one saw that, and he might have appeared on a couple of radio shows. But generally, he kind of flitted in and flitted out. There was a PR association, PRINS, that was going to be hosting him in Auckland. A lot of people contacted them, including their own members, and said, "Hey, we don't see why you're doing this. Doesn't seem relevant." And so they eventually dropped him from their schedule in Auckland, although there were some members of the same association that had some kind of lunch with him in Wellington. But generally, it was like a tree falling in a forest. It happened and went, and really no fuss. So, which I guess he's going to probably encounter more of that treatment, the crazier and wackier he gets when he moves around the world.
Yeah, I did see one video from New Zealand, which was a New Zealand journalist interviewing Moncton, and actually querying Moncton about why was the sources that Moncton, like the scientists that Moncton quotes, why were scientists saying the opposite to what Moncton was saying?
Yeah.
So for example, when Moncton would quote a scientist, and then someone would ask that scientist, "Is this what you really said?" And the scientist would say on record, "No, he's misrepresented me. I actually said the opposite."
Right.
And this New Zealand journalist cited several examples of Moncton doing this. And Moncton got quite annoyed with the journalist and dismissed him with an imperious "off you go" at the end, which was quite entertaining, I thought.
He can be very condescending, can't he? He's like, "I'm the Lord, and you bugger off, little man." Yeah, it's quite it's almost like I don't know, some kind of British comedy skit or something. But anyway, let's move on from him. He's been and gone. He may never come back. Debunking today the argument that humans aren't to be held accountable for all the CO2 that's being pumped into the air.
Yes. Before I do that, though, can I just give you the short URL?
Oh, of course.
Of my new feature?
Are you going to do it in a Monktonian manner?
No, I'm not going to do that. Whenever I try to do those kind of accents, so by the end of the sentence, I always end up sounding like Patrick Stewart. Yeah. So I'm not going to subject anyone outside of my family to that. So the address is sks.to/skeptics.
Okay, excellent.
Skeptics with a K.
All right. Humans aren't causing the rise in CO2 levels. Is that true, John?
No, it's not true. Well, firstly, when you look at all the various spectrum of climate denial, you have the more sort of complex level of denial, where at one end where people arguing about climate sensitivity or how serious the impacts are, and at the other end you have people just flatly denying that climate change is happening or that global warming is happening. But what we're looking at today is something that's even more simplistic and I think silly, and that's to say that denying that humans are even rising CO2 levels in the first place. And so the first things first is I like to look at just how do we know that humans are causing the rise in CO2? Because what we observe at the moment is that each year the amount of CO2 in the atmosphere is going up by about 16 billion tons each year.
Right.
Now what humans are emitting into the atmosphere is about 30 billion tons. So it's nearly double the amount that CO2 is rising by each year. So nature is actually absorbing or nearly half of our CO2 pollution.
Okay.
So that's the first piece of evidence, just the fact that we're throwing up 30 billion tons of CO2 into the atmosphere every year. Now, the second piece of evidence is there are various signatures or various types of carbon atoms. There's the lighter carbon-12 and the heavier carbon-13, which they're like different isotopes, or we'll just call them different types of carbon. Now, plants prefer the lighter form of carbon, which was carbon-12, And the way I'd like to remember it is I imagine that plants are just trying to cut down on their carbs. So they just stick to the carbon, or they use more of carbon-12 than carbon-13.
Right.
Now, as fossil fuels come from plants from millions of years ago, what that means is if we burn fossil fuels, so we should see the ratio of carbon-12 to carbon-13 in the atmosphere going up if fossil fuels are the cause of the CO2 rise. And that's exactly what we observe. Now, the third piece of evidence, that...
But we don't have to look at the graph now if you don't want. We're gonna.
No, I love graphs.
Okay.
I'm always happy to look at graphs. And this was going back to my first point, because when we look at how much CO2 we've been emitting, we really didn't have much of an impact until the Industrial Revolution.
Yeah.
And then over the last 2 centuries, there's a real spike where our CO2 emissions have really spiked upwards.
So we're looking at a graph that has human carbon dioxide emissions. It starts at 4000 BC and it's flatlining right at the bottom, 0, all the way through to 1800s, 1700s?
Yeah, about 1850, I think, is when it really starts to kick in.
And the thing just spikes right up. Right.
Yeah, so that top box is how much CO2 we're throwing up into the atmosphere.
Okay.
Now, the second box is the actual amount of CO2 in the atmosphere that we've measured, and that's the green and the blue line are from ice core records, and the purple line are direct measurements, and that's spiked. It shows you an identical shape to our CO2 emissions, so it's not really that much of a stretch of the imagination to think that if we throw CO2 up into the air, then we're going to see an increase of CO2 in the atmosphere. So now the third piece of evidence that humans are causing the rise in CO2 is there is a third type of carbon atom called carbon-14, and this is actually a radioactive isotope, which means that it decays over time. It has a half-life of about 6,000 years, so that fossil fuels, which were formed millions of years ago, have no carbon-14 in them. So that means that if fossil fuels are burning of fossil fuels are causing the rise of CO2 in the atmosphere, then we should also see a drop in the ratio of carbon-14 in the atmosphere.
Right.
And again, that's exactly what we see. So we have these multiple lines of evidence: the carbon-13 ratio, the carbon-14 ratio, that all point towards fossil fuel burning as the rise in CO2.
Okay, and so who is this? I mean, who normally puts out this argument, and how do they normally explain it?
Okay, so over the last few weeks, a scientist who's based at Macquarie University in Australia, Murray Selby, he gave a talk which is just available online as an audio file, and basically he argued that humans aren't the main cause of the CO2 rise. Instead, it's actually warming that is causing the CO2 to go up. And the way he worked this out was he looked over the last few decades of CO2 and of temperature, and he noticed that when temperature was warmer for example, during an El Nino year, then the rise in CO2 was actually higher. But when it was cooler, for example, during the Pinatubo eruption, which dropped global temperatures, he noticed that the rise in CO2 was slower. So basically what that means is that warmer temperatures causes the oceans to either give up CO2 or absorb less CO2. So basically there's a link between more warmer temperatures and more CO2 in the atmosphere.
Right.
But this is over short term, from year to year fluctuations. But the mistake he made was to say that, well, if temperature has an effect on CO2 over the short term, that must mean that the long term increase has nothing to do with humans.
Yeah.
It must be due to temperature as well. And this is wrong for several reasons. Firstly, because as we looked at before, we have a physical explanation for why the CO2 is going up because we're throwing 30 billion tons of CO2 into the air every year. And his explanation doesn't physically explain what's happening to all the CO2 that we're throwing into the atmosphere. Why would that not be causing the rise in CO2? The other problem is his numbers just don't add up. He estimates that over the last century we've had almost a 1 degree of warming, and CO2 has gone up by about 100 parts per million. So if you take those numbers of 1 degree equating to 100 parts per million, 20,000 years ago, when we were back in an ice age, the global temperature was about 5 degrees cooler than now. And that would mean that CO2 would actually be down in the negative values. It's just physically impossible.
Right.
And the way he responds to these failures of his model is he questions the temperature record. He says that the temperature record must be exaggerating the warming trend, and he also questions the ice core record, the CO2 values in the Earth's past. So basically what he does is whenever the empirical data contradicts his model, he denies the empirical data.
Right. So he basically says that other scientists haven't done their work correctly.
Well, he says that there's too much uncertainty in the ice core record, and he questions the temperature record. He for similar reasons that climate deniers have been questioning the temperature record for over the last few decades, saying that there's urban heat islands or there's air conditioners, or all those common denier myths, which have been analysed in the peer-reviewed literature and shown to be false. But it's just interesting that I guess that's the common tactic of the climate denier, is only pick and choose that empirical data that supports your argument and then deny anything that doesn't back up your position. But what you need to do as a genuine scientific skeptic is look at all the full body of evidence and consider it all together. And when you do that, his argument just doesn't hold up.
And yet again, it's another denial that if it was just sort of put out there in the media, it would confuse you, because you think, well, he sounds like he knows what he's talking about. But luckily, you have a short URL directly to the Skeptical Science website where you can read up about it. What is the short URL?
sks.to/Salby, Salby.
All right, we're on the home stretch now with my co-host John Cook. Because this feels like it's been a speedy show, doesn't it? Feels like we're on the motorway.
Yeah, I think we can safely blame Gareth for the long shows now.
Yeah, but judging by today's experience. So first up, let's look at something called Strawberry Tree, and I saw this linked from somewhere. But anyway, it's senergy.rs. And, well, what is it? It's a public solar charger for mobile phones invented by a group of students from the University of Belgrade. Now, it's basically a central column out there, looks like, with a seat around it. And on top, a bunch of solar panels. At the bottom of it, of course, all sorts of plugs where you can plug in your mobile device or your iPod or whatnot. And I guess they've got a whole lot of various different connections, because you can never find the right connection when you don't have it handy. But hopefully this thing has something for your iPhone or your Android device or whatever. Yeah, it's kind of cool. I thought I'd mention this one because it highlights an innovative use of solar technology and solar panels. I mean, I don't expect this would be rolled out all over the place, and I'm pretty sure this is the only one that actually exists. But it just shows the potential for solar in applications in ways that perhaps most people might not have thought about. And I know you can get these kind of devices personally. You can have a little solar charger at home. In fact, I saw, I think Belkin produces one that I saw in a catalogue the other day. Quite cheap and effective. You just plug in all your USB devices into it, and I guess put it on a windowsill so it catches the sun. But this is on a public scale, and I mean, I don't know how many times, John, you've been out in public and been caught short of power, that is, and need to plug in.
It's incredibly annoying whenever I need to make a call and then my Android's gone flat.
Yeah.
So
I mean, it's great.
the iPhone 5 comes out next month.
Yeah.
I'm imagining hundreds of people lining up outside the Apple Store to get their phones, and then all lining up in front of this tree to get their iPhones charged up.
I mean, these are, I suppose, great solutions while they're still developing the battery technology. I mean, as great as these smartphones are, and as helpful as they are, they don't last as long as the old phone that just makes calls and sends text messages. Most people, if they're a heavy user of their phone, are going to struggle to get through a working day without plugging it in somewhere. So I'd like to see one of these in Auckland. That'd be great.
Wonder whether it would have enough juice to charge up the iPad.
Yeah.
I imagine an iPad user would come in there, plug theirs in, and everyone else's phones would just all go dead.
Yeah. I mean, I could see problems here, if people have an expectation that it's going to work all the time and it's on a cloudy day and suddenly they find there's not enough power coming from it. I think this is hooked up to the electrical grid, so maybe there's a backup there, so that if there isn't enough solar going on, then you're just drawing it off the grid. And maybe vice versa as well. If there's heaps of solar, maybe it feeds back into the grid as well. That's always, of course, possible with these kinds of devices. So that's very cool. That's called Strawberry Tree, and the links for that in the show notes. Otherwise, senergy.rs. Follow the links there. On to another solar story. I found this one on CNET, and I think we mentioned something like it on a show further back about introducing solar panels onto the road. They've actually gone and done it, but not in the context of a road. They've put it on a car park. The story says here, it looks like roads that use solar power to melt snow are just one step closer to becoming a reality. So this would have been good to have in Wellington or Christchurch this week. At least for a little stretch of Idaho where it's happening, Solar Roadways received $750,000 from the Federal Highway Administration to build a parking lot paved with solar panels. Last year, the Green Infrastructure Company demoed a 12 by 12 foot prototype of its solar road, and if you're watching the live video stream you can see a picture of that. As phase one of this new technology, the prototype is made up of solar panels, heating elements, and a grid of wireless LED lights encased in durable glass that has the same traction as asphalt and doesn't cause glare, and the panels generate a total of 7.6 kilowatt hours of electricity per day that can be used to melt snow and ice. So apart from perhaps being useful to feed electricity back into the grid, it's useful in the winter to clear roads. And I know they've been having huge issues down south in New Zealand with the snow. I mean, we're not that prepared for snow in New Zealand. They're way more prepared in the States. But the graders, I think, we're having quite a few issues clearing snow away and getting the cities moving. Because in New Zealand, everything just shuts down when it snows. So that's kind of cool. Probably no use for it in Brisbane.
No. Although I could see a lot of applications coming from just the fact that they can broadcast messages on a road.
Yeah, well, that's true. Yeah, yeah.
I imagine it would start off with just slow down or
yeah,
that kind of those kind of messages. But it wouldn't be long before advertising companies would start putting buy Coke or just do it.
That could be an issue.
Logos.
Yeah, particularly if what we're saying was controversial and made people sort of look twice. I guess it's a good thing to be looking at the road when you're driving. They do say keep your eyes on the road, but could also be dicey at the same time. For those watching live video stream or the YouTube video, you can see how they're planning on rolling this out across highways as well. But so that's cool. So they're going to put it in a car park in the meantime. All right, another
I seem to remember.
Yep.
I seem to remember hearing about some tests where they had these speedometer devices that just measured how fast the car was moving, and then if they were speeding, it just broadcast a digital message saying you're going too fast.
Yeah.
Here's your speed, and just that reporting of people's speeds was the most effective way of reducing speeding on the road. Maybe they can apply this to that kind of testing to this kind of technology.
Well, actually, I know that those we have those in New Zealand, and they are reasonably effective. On some roads, you'll have a digital readout that I guess it's got a radar gun that's pointing at the car, and it will tell you your speed. And when you go over, say, I think the threshold is 10 kilometres over the limit, it'll say slow down. And I know that's reasonably effective. I know when I'm driving around and it says slow down, I go, oh, I must be going over 60 or whatever. And actually, those things are normally solar panel. They've got a solar panel on top as well. And I know some school signs around Auckland have got solar panels on top. So that's pretty effective. Staying with solar panels and also car parks as well. This story here, another one from CNET, at the University of California, they have deployed something called an Envision solar carport. They have a vision to have large solar installations all over the university, but they've started off, they're going to be clearing some trees away. Now, I guess this, as the story goes, it says it's one of those rare instances where cutting down trees is actually necessary to reduce carbon emissions. But they're cutting down some trees in the car park, and in place of having the trees there, they're having big, effectively, carports with solar panels on top, which is a really good idea and a good use of space. That's why I wanted to talk about this story, because when you think about what is normally sort of dead space or unused space, I mean, you obviously you're parking a car there in the car park, but why not have something over the top? Even though it's not a car parking building, it is just a flat one-story space. Why not just have something over the top that would normally just be air, and fill that space with something that's going to harness the sun's rays? I think this is a brilliant idea, especially if in a place like Idaho, which probably sees a lot of sun.
I imagine a future utopia where everyone's driving electric cars, and when we go to the shops, we just plug our cars into the solar-powered carports, and they charge our cars up while we're shopping.
Yeah, wouldn't you? Absolutely.
Maybe in a few decades we'll get there.
Yeah.
Maybe within a decade.
And I mean, if electric powered cars were ubiquitous, this would pay for itself. And you probably put in $1 or $2 into a little meter there in the car park, and pay for that solar power that you're using as well, which should in turn pay for implementing and putting in the solar panels in the first place. Yeah, I just thought those were some nice stories, and I noticed there are a lot more solar panel stories coming up in the green tech news feeds, and it must be because the solar panels are coming down in price. Although at the same time, in this very same CNET news feed, I was seeing some stories about some solar panel companies in the States closing down, but what I got from those stories was that it was due to heavy competition, and that may be because China is tuning out a lot of solar panels, and they may be doing it a whole lot cheaper than what they're doing in the States, which I guess is no good for the United States economy. We know there's certainly big issues there, but at the same time,
I heard last night they had a documentary about renewable power, and I think off the top of my head they mentioned that China's investment into solar power was about a quarter of the global investment in solar power.
Crikey, yeah.
So China is on this trajectory to really dominate the solar market at the moment.
I'm ready for it. Give me cheap solar panels.
Yeah, I mean that's really the key, is that the solar industry needs to keep growing so that the price keeps coming down.
Yeah.
And they mentioned last night that the amount of sun that the Earth receives every day is equal or is more than the amount of power that humans use over a whole year. So as you say, if we can utilize that dead space, the carports and roofs everywhere, then that's a big slice of the pie in solving our energy problems.
And I know Josh, on the interview a little bit earlier, he was saying the same thing for the States, that if all this investment that was going into the technologies like fracking and extracting coal and burning coal and whatnot, if all that money was poured into renewable sources of energy, they could easily replace most of what's being consumed in the States at the moment. But there we go. So that's the solution segment, and I think we've reached the end of the show just like that, John. Pretty simple. Thanks so much for sticking around for the whole entire show. I don't know if I could do it really by myself. There'd be no one to bounce things off. I'd be talking to thin air.
Yeah. That was less painful than I thought it would be too.
You're a fantastic co-host, and maybe I guess we might be doing this in another couple of weeks. I don't even know when Gareth gets back or where he is at the moment. I've heard nothing from him, which is probably a really good sign for him because it means he's totally relaxing somewhere nice and warm, and far away from freezing Waipara at the moment. So good on him, I reckon. Good on him.
Well, if he gets onto the internet somewhere and sees this show, he'll probably be hurrying back to New Zealand.
Yeah, be like, what have you done? What have you done to the Climate Show? Alrighty, well, if you want to subscribe to the show, you can. It's easy to do that in your favourite RSS player, and all the links are available at theclimateshow.com in two flavours, audio and video, through the YouTube. Don't forget you can also subscribe to the Radio Whammo YouTube channel, where you'll get the video automatically through there as well, and other apps like Stitcher.com on your mobile device, Android or iPhone or BlackBerry, and whatever else you have as well. And don't forget to join up on the Twitter page, twitter.com/The Climate Show, and also facebook.com/The Climate Show. And as I said, theclimateshow.com and hot-topic.co.nz. Until next time, which will hopefully be in 2 weeks, John and I will be joining you then. Thanks very much, John. We'll talk to you then.
See you later.
What good is a drop in the ocean?